This video will explain why we need to edit what we call topography noses on when we're creating a digital terrain model. So for example, if I hit report and elevations, you can see we have a 900, a 910, and 920 elevation, and we can see how the contours wrap around each other. So when the computer goes ahead and then creates a digital terrain model, for example, go to Topo and we'll create one, you could see what it sees is a flat area with some influence of the difference of the elevation with the topo around it. But essentially, this is flat, and this is flat to the computer. So what we have to do, I'm going to hit cancel so we get rid of that, is we typically go on a different layer, and then we define with line work, which these are called break lines, and allow the line work to follow the topo. Now, what happens with these lines is that when it creates a digital terrain model, it actually won't create triangles that cross these lines. And that's essentially what a break line is. So this area here will still be flat because we don't have a point of a different elevation that we could address. We could go into drafting and digitize, for example, 890 and just put a point here and a point there so that we can create a line from that 890 foot here and here. But typically we don't have that information and we're coming in right from survey or an existing aerial file. Now, when we create topography and we create a digital terrain model, now we can see the roadway, we can see the ditches, and we can actually do this because there's a kind of an even transition here. We can then go ahead and erase these lines as long as there's an even transition, which there appears to be. And because we have those break lines there, we can eliminate data. I'll eliminate 16 points, for example, but we still have that definition through there. I'm going to say delete the surface from memory. So now I don't have the digital terrain, and I'm going to recompile that. I'm going to create a new digital terrain model, and you can see it's essentially the exact same thing with 16 less points. Here you can see a properly set up topography to be reduced to a very efficient digital terrain model. Now the black lines are the original ones that we are keeping because they are unique in nature. The red has no filtering, so this is the original data. We didn't want to reduce any accuracy of the data or reduce any points in it. The light blue lines you see are the break lines to help guide the noses, and we're still working on that. And then the magenta lines, if I was to take those out, for example, they're on layer 13, edit, delete by layer, just take out those, and then edit and delete unused points. Those are 22,081 points we don't need because we'll replicate the surface without those points. So you can see these are essentially the guidelines that are going to create a new digital terrain model with a fraction of the data of the original number of points, so that all of the work goes through very fast. The engineering, the earthwork, and everything is going to happen much faster without any degradation of the accuracy. And by the way, even if we didn't filter this data down, you would still need to define these noses to get any kind of accurate data out of it. So it doesn't matter if you're using LandMentor like this package or AutoCAD or any other package. It's going to require someone to go through and define these noses if you want any kind of accuracy within the system.